We'll see a theorem. Every convergence sequence is bounded. We'll see how every convergence sequence becomes bounded. So we take a convergence sequence. By definition of the convergence sequence, we have limit of xn when n tends to infinity is equal to L. Again, by the same definition of the limit, by limit definition, we have for every epsilon greater than 0, there exists a m which belongs to n such that the absolute value of xn minus L is less than epsilon for every n greater than m. This means that whenever n become greater than m, xn are the members of the sequence. We have x1, x2 till x infinity. So when xn crosses xm, okay, when n greater than m means all those elements where n greater than m, okay, all those xn's becomes very close to the limit L. The difference between xn and L is made very small, almost equal to epsilon, which is a quantity which lies between 0 and 1. It is a very negligible positive quantity. Now what we do is we take this inequality and we break it up. How do we break it up? So absolute value of xn minus L is less than epsilon. So when we remove the sign, we can take it as when we remove the sign, when we remove the absolute value sign, what we get is minus epsilon less than xn minus L less than epsilon. How do we get that? When you put positive value, see absolute value means it can be positive or negative. When you take the positive value, you will get this xn minus L is less than epsilon, the right side inequality. When you put minus sign, you will get minus of the whole of xn minus L is less than epsilon. Okay, you multiply that throughout with the minus sign. So the minus sign is gone from the left side. It goes to the right side. What you get will be xn minus L is greater than minus epsilon. So there we get the left-hand side inequality. So when we remove the sign, we are writing a combination of both. Now what we do is we add L to this, all the members in this inequality. We add L. So here you will get L minus epsilon less than xn minus L plus L, which L will get cancelled, and right side we get L plus epsilon. So we have L minus epsilon less than xn less than L plus epsilon. Okay, and for every n greater than m, this happens for every, so removing few terms from the beginning, those m terms, we are removing those m terms from the beginning, we get the inequality true for every n. Now we have a few quantities here, like some members of the series, which is x1, x2, x3 till xm minus 1. And then we have L minus epsilon, we have L plus epsilon, where L is a limit. Okay, we'll take the minimum of all those quantities as small letter k and maximum of all those quantities as capital K. We have to prove that the convergence sequence is bounded. So we are looking for bounds. So we are designing two bounds, which is a lower bound and upper bound. So we take the minimum of all the quantities which we know as a lower bound and the maximum of all the quantities which we have right now as the upper bound. So now we'll put it as k less than L minus epsilon. That is how we took small letter k, less than xn, less than L plus epsilon, less than or equal to k. Okay, we have just included k, capital K and small letter k in this inequality, because that is how we took small letter k and capital K. So we can place it in the extreme left and on the right. So we get this inequality. Now what we do is we'll take only, we'll leave out this L minus epsilon and L plus epsilon. we include only small letter k less than xn less than capital letter K for every n belongs to n. So k less than or equal to xn less than or equal to capital K for every n member of the set of all natural numbers, which is the definition for a sequence to be bounded. So hence we have our sequence xn has got a lower bound and upper bound. So it is bounded from both sides. So it is a bounded sequence. So hence every convergence sequence is bounded. Thank you.